Section 10.7 on polar coordinates. So the polar coordinate system is a two-dimensional coordinate system in which each point on a plane is determined by a distance from the fixed point and an angle from a fixed direction. So the ordered pairs in polar form are r comma theta. R is your directed distance or radius, and theta is your directed angle. So the graph to the right-hand side is a polar graph. If you notice the concentric circles, that would be your radius. So each circle represents 1. And then we have angles going around the circle from 0 to 360 degrees. So if I'm going to plot the point 3, 75 degrees, then I'm going to go out 3 circles and around to 75 degrees. And so this point right here would be 3, 75 degrees. Now that point could also be found by going to the 75 degree mark and then out 3 circles. So it works interchangeably with polar coordinates. I could also rename this point several different things because we know that these angles continue around. I can add 360 or subtract 360 and get another angle measure. So there's lots of different ordered pairs that would land me at the same spot. Next we have coordinate conversions and the equations that we'll use to convert the equations. We have polar to rectangular. So if you are given a polar coordinate, an r comma theta, and you want a rectangular coordinate, which is an x comma y, then you're going to plug them into the first two equations. X equals r cosine theta and y equals r sine theta. On these, you want to pay particular attention to what type of angle you're given. If you're given a radian, you need to be in radian mode on your calculator. If you're given a degree, make sure you're in degree mode. Then next we have if we're converting from rectangular to polar. So if I have an xy coordinate and I want an r theta. So we're going to use tangent theta equals y divided by x. And then to get theta, I would just take the inverse tangent of y over x. Then to find the r, we're going to use the equation r squared equals x squared plus y squared. So to get r by itself, we would take the square root of x squared plus y squared. Okay, so now we're going to work through several examples. So we're going to start by graphing the polar coordinate 4, negative pi over 3. So since my polar coordinate system is in degrees in this picture, I'm going to go ahead and convert my coordinate from radians to degrees. So if you remember a long time ago from trig, to go from a radian to a degree, we're going to multiply by 180 over pi. So when I do that, my pi's are going to cancel. And I know that 3 goes into 180 60 times. So this is equal to negative 60 degrees. So when I'm graphing my point, negative 60 degrees, instead of going up and to the left 60 degrees, we're going to go down to negative 60, which would be the same as 300 degrees. So we're going to go out 4 circles and then down to 300 degrees, which would be equivalent. So the point 4 comma negative pi over 3 is the same as 4 negative 60, or also 4 comma 300 degrees. Either one of those would work. Okay, so on number 2, we're just going to convert this one from a polar coordinate to a rectangular. So we're going to use the two equations, x equals r cosine theta and y equals r sine theta. So x is going to equal 3 cosine pi over 2. When I type this into my calculator, I need to be in radian mode, and we're going to get 0. Then for the y, we're going to type in 3 sine pi over 2, and you should get 3. So graphing the point 3 comma pi over 2 on the polar coordinate system would be the same as graphing the ordered pair 0, 3 on the rectangular system. Okay, now number 3, we're going to go from a rectangular coordinate to a polar coordinate. So this time we're given an xy, I want an r theta. So I'm going to use these two equations, x squared plus y squared equals r squared, and tangent theta equals y over x. So, negative 3 squared plus 4 squared equals r squared. So when I type this into my calculator, this means that r squared equals 25. And then when I take the square root, I get that r equals 5. Now to find the angle, we're going to say tangent theta equals 4 over negative 3. And then I'm going to take the inverse tangent of 4 over negative 3. And since this is, my calculator is still in radian mode, this is a radian angle, negative 0.93. So I would write this as 5, negative 0.93. Okay, so the next few we're going to be converting equations from polar to rectangular and vice versa. We're going to use those same 4 conversion equations, we just may use them in different ways. So you don't necessarily have to say, oh, this is rectangular to polar, I only use these 2. We're trying to use any of those that might be helpful. So I'm seeing the x squared plus y squared, and I remember earlier x squared plus y squared is equal to r squared. And when we want a polar equation, we either want r equals or theta equals, something with an r or a theta. So to get r by itself, we're going to take the square root of 9, which will be r equal 3. So the equation that we were given was the equation of a circle with a radius of 3. And so this r equals 3 is also equation of a circle in polar form with a radius of 3. Okay, so on number 5, we're going to convert from rectangular to polar, x equals 10. So I know that x is equal to r cosine theta. So I'm going to write r cosine theta equals 10. And I want r by itself. So I'm going to divide both sides by cosine. And that's going to give me r equals 10 over cosine. Now, if I was using my calculator to graph this, I would leave it just like this, 10 divided by cosine theta. If we were in a trig class, it wouldn't be proper to leave the cosine on the bottom. And remember from a long time ago that 1 over cosine is equal to secant. So r equal 10 secant theta is the same as 10 divided by cosine theta. I would be okay with either answer. Okay, number 6, again, we're going to convert from polar to rectangular. So I want to get rid of my r's and thetas, and I want only x's and y's. So what I want to do on this one is I want to multiply by r on both sides. So then I'm going to have r squared equals 4r sine theta. Well, I remember that r squared is equal to x squared plus y squared. And then on the right, I have 4, and I remember that r sine theta is equal to y. Now, I could leave it like this or just move everything to one side of the equation. It really doesn't matter. If you can get to this point, this is what we're looking for. We've got only x's and y's, all the r's and thetas are canceled out. So x squared plus y squared minus 4y equals 0 would be the rectangular equation. Okay, last one, number 7, r equals 4. This time, instead of multiplying by r on both sides, I'm just going to square both sides of the equation. So this would mean r squared equals 16, and I know that r squared is x squared plus y squared equals 16. So this, again, is the equation of a circle with a radius of 4, and so is r equals 4.